Hello everyone. Today we will see what is augmented reality and some points of virtual reality. So augmented reality and virtual reality, these are emerging as crucial technologies in the industry 4.0, which is driven by the industrial internet of things. And these technologies, these will enhance the industrial operations by improving efficiency, safety and productivity. Industry 4.0, it refers to the fourth industrial revolution, which integrates smart manufacturing, automation, data exchange, and industrial IoT. These augmented reality and the virtual reality technologies are used to bridge the digital and physical worlds, allowing the real-time interaction with the industrial process. These are some of the applications of the augmented reality and the virtual reality in the industrial IoT. First is optimization and productivity in manufacturing. Here, the augmented reality and the virtual reality, these will assist in or help in designing the prototyping and optimizing industrial processes before the actual production. And the engineers and the designers can use the virtual reality simulations to test different configurations without physical prototypes. And AR-based smart glasses assist factory workers by overlaying real-time machine data, assembly instructions and alerts, improving efficiency and reducing the errors. Example is Boeing, which uses AR, that is the augmented reality, to guide the technicians in assembling complex wiring for aircraft, reducing the errors by 90% and increasing the speed by 25%. Second is AR for warehousing efficiency or warehouse efficiency with the augmented reality, where the augmented reality enhances the warehouse management by guiding the workers to locate items quickly and optimizing inventory tracking and reducing the errors. And AR powered devices like smart glasses or handheld tablets, these can display the real-time inventory data and guide the workers to the exact location of the parts or the products. For example, you have DHL implemented AR smart glasses in the warehouses, which result in a 25% increase in efficiency by optimizing the order picking process. Third is the safety training and hazard prevention, where the VR-based simulations provide the realistic training for workers in hazardous environments, reducing the risk of workplace accidents. And AR can overlay hazard warnings and safety instructions on equipment, alerting the workers to potential risk in real time. And example for this is oil and gas industries, which use the VR, that is a virtual reality, in order to train the workers in handling dangerous situations such as gas leaks or fire emergencies in a risk-free environment. Then you have integration with industrial IoT sensors, that is integration of the augmented reality and the virtual reality. So here the augmented reality applications use industrial IoT data from machines, sensors and cloud platforms in order to provide the real-time operations insights to factory workers. And the VR-based predictive maintenance, these will use the industrial IoT data in order to simulate machine failures before they happen and reduce the downtime. Example is the General Electric, where it uses the AR powered digital twins in order to monitor and predict the performance of industrial equipment using the industrial IoT data. These are some of the use cases of the augmented reality and the virtual reality in the industrial IoT. First is the machining and the production. Okay, machining and the production, where the AR provides the real-time operational data to workers for precise machining, and VR simulations optimize the machine configuration before actual production. Examples are the AR-powered CNC machining, which enhances the accuracy and the efficiency. Second is education and the collaboration, where the VR based virtual training environments improve the workforce skill development. And these AR, it allows remote experts to guide technicians in the real time. Examples is companies like Siemens. These will use the virtual reality for training engineers in industrial settings. Then you have assembly, where the AR, it will over-relays step-by-step assembly instructions to reduce the errors, and smart glasses display the real-time guidance, minimizing the need for manuals. Example is Airbus uses the augmented reality for aircraft assembly, improving the efficiency by 30%. Then you have safety and security, where the VR provides the hazard simulations for safety training, and AR highlights the potential risk and provides real-time safety alerts. Examples is oil and gas industries, which uses the virtual reality emergency drills to train the workers. Then you have digital prototyping, where the VR allows the engineers to visualize and test the prototypes before the production and reduces the material waste and the development cost. Example is the Ford uses the virtual reality in order to test the vehicle designs before manufacturing. That is a Ford company. Then you have factory planning, where AR and VR, these will help in layout planning and workflow optimization, and it reduces the inefficiencies by simulating the real-time factory operations. Examples is BMW, these use the AR, that is the augmented reality, for factory floor design and improves the space utilization. Then you have maintenance and production. Here, AR will enable the real-time diagnostics and predictive maintenance using the industrial IoT data, and the technicians uh, get overlaid repair instructions via the smart glasses. Example here is a General Electric, which uses the AR, that is the augmented reality, for the turbine maintenance, reducing the downtime. So these are the 7 use cases which are used in 7 use cases of the augmented reality and the virtual reality. Then you have, now we will see what is augmented reality. Okay, so augmented reality, here it is an enhanced version of the reality, where the digital elements are added to the physical world. Okay, so augmented reality is an enhanced version of the reality where the digital elements are added to the physical world. Now how it works? Here AR, it will over-relay the computer generated images, data or animations onto the real world environments, and it can be experienced through the smartphones, tablets, then AR glasses or the headsets. The key features are real world interaction. Like, unlike the virtual reality, the AR will not replace reality, but it enhances the reality. Okay, in virtual reality, you have like it will replace the reality, whereas in augmented reality it will enhance the reality. That is nothing but real world interaction. Then real time augmentation is the digital content, it will appear instantly in response to the user's environment. And improved perception is the AR, it will amplify the present perception of reality with the interactive elements. Okay, so these are the 3 key features. First is real world interaction, real time augmentation, improved perception. And examples are Google Lens, that will scan the real world objects and provide the instant information. Then you have IKEA Place app, which allows the users to place virtual furniture in their homes. And you have AR based smart glasses, which will assist in industrial maintenance by displaying the real time machine data. Okay, so here we have seen the definition of the augmented reality, then how it works, key features and the examples. Next is key features and applications of augmented reality. So here the first is part of mixed reality spectrum. Okay, here mixed reality spectrum, That is the augmented reality. It lies between the fully physical reality and completely virtual environments, and it will blend the real and the digital environments. Okay, that is nothing but mixed reality spectrum. What it is? The augmented reality, it will lie between the fully physical reality and completely virtual environment, and it will blend the real and the real digital environments, okay, or the elements. Second is multisensory experience. So here the augmented reality, it provides multiple sensor modalities, which includes visual, auditory and haptic feedback. Visual is overlaying the images, 3D models and the text. Then auditory is voice commands and the sound effects. And haptic feedback is vibrations or touch sensations in the augmented reality devices. And next is the digital overlays. That is, overlays digital information on the real world, where AR utilizes the real world environment and superimposes the interactive digital content. That is the text, graphics, animations or the real-time data. Okay, and some of the examples are Google Maps live view. Here, that is, applications are Google Maps live view, where the augmented reality, it overlays navigation arrows on the real world streets. Then you have, like here you will be using your Google Maps. Then you have medical AR applications, where it will help the surgeons to visualize the organs during the operations. Then you have AR smart glasses in the industries, which will display the real-time equipment diagnostics. Okay. Next is the chronological order of the augmented reality developments. So here, uh, L. Frank Baum, he proposed electronic display spectacles in the year 1901. Okay, that could overlay information on the reality. Then Gavan Linton in 1980 from University of Illinois. So he published the concept of a head-up display, that is HUD is nothing but the head-up display for training the pilots in the real-world fight skills. And in 1990, Thamos Caudill, he was a Boeing researcher and he coined the term augmented reality while developing AR applications for aircraft assembly. Then in 1992, Louis Rosenberg, he developed the first functioning AR system at the US Air Force Research Laboratory. And in 1999, like US Naval Research Laboratory developed the battlefield augmented reality system, that is the BARS. BARS is what? It is battlefield augmented reality system in order to assist soldiers in combat scenarios. And in 2013, Google launched Google Glass, a wearable augmented reality device that displayed real-time information in user's view. Okay, this is the chronological order of the augmented reality. These are some of the applications of the augmented reality. The first one is the entertainment. Here, AR enhances the gaming, then movies and interactive experiences. Example is Pokemon Go overlays virtual creatures onto the real world environments. Then you have flight training. Okay, here, that is AR based head-up displays, that is hoods. These will assist pilots in navigation and training. Example is AR flight simulators, which will provide the real world scenario practice. Then you have education, where AR powered guides will provide real-time historical and cultural information at the landmarks. Example is the Google Lens translates foreign signs and provides AR based directions. Then you have retail, where the AR will assist or allow customers to try on clothes, glasses or furniture in virtuality. And example is IKEA Place app, which will let the users to visualize furniture in their homes. Then you have industrial design. Okay, so industrial design is here the AR will assist in prototyping and product visualization before the production. Example is car manufacturers use the augmented reality for designing the vehicle components. Then you have medical. Okay, here the augmented reality, it will help in surgical planning, then diagnostic and medical training. Example is Microsoft HoloLens aids the surgeons by overlaying the 3D models of the organs. Next is military, where the AR will provide the real-time battlefield data, target tracking and training simulations. Example is the Battlefield Augmented Reality System, that is the BARS, which enhances the soldier situational awareness. And last is the Industry 4.0 and Industrial IoT, which where the AR improves the manufacturing, maintenance and real-time monitoring in the smart factories. And example is the Boeing uses the augmented reality smart glasses for aircraft assembly and reducing the errors and increasing the efficiency. Okay, I think this is applications. This is not applications of AR. This is the key components of AR. Okay, so key components of AR are, first is the sensors and the cameras, where it will capture the real world environment and track the movement, and which is used for depth sensing, object recognition and real time mapping. Example is the augmented reality glasses, which uses the cameras to scan the surroundings and overlay the digital content. Then you have projection screening. Here it will display the digital content over the real world, and it can be transparent or screen based. If it is transparent, then you'll be using the AR glasses. If it is screen based, then you'll be using the smartphones, tablets and the headsets. Example is the AR powered head-up displays, hoods in cars, project navigation information. Then you have processing unit. Here it is the core computing unit which will process the augmented reality data in real time, and it uses the AI, that is the artificial intelligence, machine learning, cloud computing for advanced applications. Here example is a Microsoft HoloLens, which has a dedicated processing unit for the augmented reality task. Then you have the reflection, where it uses the mirrors or the lenses in order to direct the AR visuals to the user's eyes, and it will enhance the depth perception and the realism. Example is the AR waveguides in the smart glasses like Google Glass. It will enable the hands-free AR interaction. So these are the key components of augmented reality. These are not the applications, these are the key components of the augmented reality devices. Okay. Then you have types of augmented reality. Okay. So the first one is the marker based augmented reality, where it utilizes the visual markers such as the QR codes, symbols or the images in order to trigger the display of the AR content. When the camera detects a marker, it differentiates it from the real world objects, and it overlays the corresponding digital content. Then you have second is a markerless AR, that is a markerless augmented reality. Uh, Unlike the marker based augmented reality, this markerless AR, it does not require predefined markers. Instead, it relies on the technologies such as the GPS, then digital compass, accelerometer and the gyrometer to provide the location based experiences. So this type of augmented reality, uh, it is commonly used for navigation and other location aware applications such as Google Maps, Live View, GPS. Okay. Then you have projection based augmented reality. So here it involves the projecting digital light onto the real world surfaces, creating the interactive experiences. And this type of AR, it will allow for human interaction by detecting the changes in the projection patterns, and it will make it suitable for various interactive applications such as holographic keyboards and the interactive AR exhibits in museums. Okay, so next is the super imposition based augmented reality, where here this will partially or it will fully replaces the real world view with augmented content. And object recognition here, it plays a very important role in this type of AR, and it is necessary for overlaying new information onto the existing environment. Example here is the medical AR applications, where the augmented reality replaces the parts of the body with 3D anatomical models during the surgery. Okay, so there are four types of augmented reality: marker based, markerless, then projection based, and superimposition based. Okay. And this is how the augmented reality works. Here it will the sensor will gather the data, that is the sensors will collect the environmental data in order to track the motion and the positioning. Then the camera will scan the environment, that is the cameras will capture and it will recognize the objects in the surroundings. Then you have processing unit which will analyze the data, so it will interpret the data to generate virtual overlays. And after that there will be a projector which will create the interaction, that is it will display the digital elements onto the physical surfaces. And you have mirrors which will assist the reflection, that is the mirrors will direct the digital content into the user's field of view. Okay, this is about the augmented reality. Thank you.